Good day, students and viewers. Today we are going to cover what is known as similarity in triangles. Similarity in triangles. Why I picked up this subject, similarity in triangles? Because it is not in the textbook. This is because this is a precursor, because you have to know about similarity before you go to congruency. Similarity before learning about congruence. Okay, what is meaning of similarity? You know two things. If you can say this is a triangle, we'll start with triangle. Because why we always start with triangle? Because triangle is the first figure which gives you enclosed space. And you will find that if I draw another triangle inside it, so these two triangles will be similar. I can draw another smaller triangle below within this. So these will be similar triangles. What is the requirement of a similarity in triangles? The first requirement that all the angles should be equal. All the angles should be equal. So let me write down A, B, C, D, E, or let's say D, it should be followed. D, E, F, the convention should be followed. We always use anti-clockwise direction in to give this numbering. So this angle 1 and corresponding angle. Remember the word corresponding. It is used very frequently in case of when you are dealing with plane figures in 2 dimensions. So what is the corresponding number? If I write this one, I will write this one 1 dash. So this is the corresponding. This is 2. This is 2 dash. This is corresponding. This is 2, 3. This is 3 dash. So corresponding has a meaning that when I am going to the figure, it is the same angle of that figure. That means this will correspond to that particular figure. So corresponding is very important. So the 3 angles, angle A should be equal to angle, we started with D. So an angle B should be equal to angle E, angle C should be equal to angle F. This is one requirement. What is the other requirement? The ratio of the sides should be same. That means if I write AB by DF, so what is that ratio? Again corresponding side. So this is this side of the triangle and this is also corresponding side of the angle. So that means if I follow this and I will land up on this side. So this is the base if we say, so I have to go to the base. So that would be equal to, I have started with that, BC should be equal to, will be proportional, not equal to EF, and this proportionality, the rest of it, AC, should be equal to DF. So, and there will be a ratio. We don't know. Let's call that ratio K, right? Okay. So this will be the ratio. So these are the basic requirement, and this is called a criteria called A, and A. So this is the criteria. This is the criteria, and this is the ratio that you should remember. Okay, what are the another requirement of similarity? That's a very, very interesting idea that you will like to know. So if I will again stick to triangle. Remember, because I can convert any figure into a triangle. Like let us say this is a regular figure of either you say rectangle or a square. I can convert it into two triangles. triangle 1, triangle 2. Similarly, suppose I have got a hexagon. I have got a hexagon. So hexagon, how do I draw? So this is the way you draw an hexagon. Okay, easiest way to draw. And say this would be its center, because you can circumscribe a circle. So if you join these, they are also triangles. And number of sides will give you the number of triangles. It has got how many sides? 2, 3, 4, 5 and 6. That's why it is called hexagon. 1, 2, 3, 4, 5, 6. And since you have this kind of a conversion into triangle, so this will be all equilateral triangle, because this is all same sides. Okay, so equilateral triangle, if I have area of any one of these triangles, so I will multiply it by into 6 and I will get the area of the hexagon. Same thing with pentagon. See, this is how we draw a pentagon, right? Okay, again I can convert it into triangles. So knowledge about triangles is very, very important, and this is absolutely essential that you prepare know about this similarity of triangles, and that's why we know we work with triangles. Okay, another area that is important, another formula that is important, this is like this one. We are going to do about the area of the triangles. What is the ratio in the area of the triangle? So we remember two things. First of all, that if these two triangles are similar, first of all, their angles are corresponding angles are equal. So this would be corresponding angle of A will be a corresponding of D, and corresponding angle of C will be this one. Okay, now we have to find out what we are going to do. And what is the other condition? What is this? That let me write down. AB by DF or DE, that is equal to AC by DF, and that is equal to AC लिया BC ले लेते हैं, BC by EF. Okay, so this ratio will be this thing if triangle ABC is equal to triangle is similar to triangle DEF. What is this sign? This sign is used for similarity. 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 Okay, so this sign is used for similarity. Remember, I just want to mention here so that for congruence you use, this is the sign for congruence. If I remove these two particular equal to sign, then it converts into similarity. Then it is no longer congruences, but this is similarity. Okay, this is it. Now I want to find out the ratio. There will be in all figures, and many of these computer graphics, they use it to show that either the area is reducing or people are going to a distance. So many times you get to see designs of like this. So this is a triangle, there will be another triangle inside it, then there will be another triangle inside it, and they will keep on showing this. You can also show that for a rectangle, there can be again similar rectangle inscribed inside this triangle. Again there will be another triangle here. Again there will be another triangle here. So this kind of computer graphics, you keep on seeing it. In case of circle, let me draw a circle. Though it's not very good, but for your purpose, this will be altogether okay. So I can have circle from the same center but of different radius. So they are not congruent, but they are similar. So you can keep on drawing this kind of this thing. These are also called concentric circles. Okay. So these are all the kind of knowledge you require in order to know the similarity. Let us do some sums on similarity. Okay. Okay, let us say I have a triangle. Okay, now this is called ABC. And this is a line PQ. Whatever is given, it is given AP is equal to 10 centimeter. My P is not being done properly. AB is equal to 20 centimeter and BC is equal to 40 centimeter. What we have to know? We have to find out what is the ratio. Okay, let us see these two triangles. So there are two triangles. Okay, the top, this is a triangle, and the bigger triangle. The bigger triangle, how do I draw it? I will draw it like this. Okay, now these two triangles, if I say, let us take this is triangle 1, this is triangle 2. Triangle 2 covers triangle 1. So this and this is also given that PQ is parallel to BC, right? PQ is parallel to BC. Have I taken that? Then this angle and this angle are corresponding angle. This angle and this angle is corresponding angle, and this angle is common to both the triangles. Okay. So we can say I have used 1, 2. So I will use this one as 3, 4, 5, 6, and I will use this one 7. So I'll write angle 3 is equal to angle 5, angle 4 is equal to angle 6, and angle 7 is common. Is common to both the triangles. Okay, what I have to find out? I have to find out PQ. What is the value of PQ? So let us pick up the ratios. What would be AB? What is AB equal to? AB is given as already given as 20 centimeter, right? A to B is equal to 20 centimeter. Okay, AP has also been given. So I can write down AP, I am taking the smaller one, AP by AB, okay, should be equal to, if I take the corresponding sides again, then AB I have started, so it will be AQ by, has it given the value of AC? No, it has not given me the value of AC, so I cannot go into that direction. So I will go PQ by BC. I have to find out BC anyway. So let us find out what is AP. AP is 10. Okay, AB is 20. So PQ I have to find out. PQ is question mark. BC I know is 40. Okay, so what will be PQ? Child's play. This is 2, this and this will be 20, so PQ is equal to 20. So you can call it units. If this is given in centimeter, then it will be, it's okay, I have taken centimeter, call these all of them in centimeter, otherwise you have to convert centimeter into meter and other kind of thing. So So that will create another problem. There is another very interesting, or not interesting, very easy, but it should occur to you immediately. As I said, in any exam, it is not only the knowledge, you have to retrieve the knowledge. Yes, I have seen this sum, and this sum will be done according to this. So that retrieval, immediate information, that you cannot say I have forgotten at that time when the time comes when somebody asks you a question. You have to retrieve this. In order to retrieve that, you have to do a lot of practice, huge amount of practice. Can you believe Messi takes a ball and can hit about 50 yards and that goes into by the corner of the goalpost? How does he achieve that? He must have hit that ball at least million times in order to achieve that feat. It's same thing with studies, that you have to keep on studying and studying. Okay. What it says that you have two triangles. Okay. And these triangles are given. One angle is given as 60, the other angle is given as 70. Okay, and this angle is given as 50. Okay, here only two are given. Say for example, here it is 60 is given and here it is 50 is given. Okay, no, here also 70 is given and this angle is not given. So they are asking, can you say whether these two are similar? So all you have to do, that you have to try the sum properties, internal sum of internal angles of a triangle. Okay, so that is would be equal to 180. So here 70 plus 60 plus this angle, let's call it x equal to 180. So x equal to 50 degree. So this becomes 50. So all the angles are same. So you can say that okay, done. Okay, let's take another trapezoid. Okay, and this is A, B, and this is C, and this is D. These diagonals are joined. Okay, and they intersect at O. So it is said that AB is parallel to CD, and this is given. Right? So prove that AO by OC is equal to OB by OD. This you have to prove. Prove this. How do you prove this? Very easy. Take these two triangles. This and these triangles. Why did I take these two triangles? Because AO and OC and OB and AD are both sides of these two triangles. So it's an easy pick. I could have taken this one and as well as this one. Okay, a similar thing may have happened, but this is, to me, this is very, very simple. And then I have to prove that these two triangles are similar first to work. So I will see that this line and this line are parallel. So this angle and this angle are alternate opposite angles. So angle 1 is equal to angle 2. Why? Why? Because because they are alternate opposite angles. Done? Okay. So 1 and 2 I have proven. Same thing. This is, if I say 3, this is 4. So again, angle 3 equal to angle 4. Again reason, why and this thing, do I will write down. Same reason, why this is. And now, angle 3 and 4, angle 5 and 6, they are also equal. Angle 5 equal to angle 6, because that is equal to alternate vertically opposite angles. Sorry, vertically opposite angles. Okay, so ABO, triangle ABO, I'll write little bit slowly so that there is no confusion, is similar to triangle ODC. Agreed? This you must agree, because this is what it is. So then I can take ratio of corresponding side. I can write AO by OC. AO by OC. So you say OC and you write OD. So that you can happen in your exam also. So you have to do a lot of practice. So AO and OC, that is equal to OB. OB, that is equal to OB equal to OD. So prove. I want to point out very, very important thing. First of all, these are similar triangles. Okay? In similar triangles, we have a condition where the three angles would be equal and the sides will be in proportion. So I have to prove the angle. But this is not a condition for congruency. Remember, if three angles are equal, the two triangles will not be congruent. So let there be no confusion about it. Okay, now I will say like this thing, there is another principle which is known as side angle side. This we have done. This is side angle side. That is SAS. This also applies for congruency also. So this will be there. Again, the other one, that is SSS, which is side and side. These two also applies in case of congruency. So remember, all congruent triangles are also similar, but all similar triangles are not congruent. So I must write it down here. And this is important. This is important for you to understand, especially for multiple year questions. All congruent triangles are similar, but all similar triangles are not congruent. Okay, remember, we will go and we will cover congruency in greater details. But just to introduce, for two figures to be congruent, one must exactly fill on the top of this. So it will be on all sides, it will be similar, and it will be do like this. So we'll stop it here today, and we will request you again to click on my this thing subscription, so that you subscribe to my channel. This is the subscription, you are doing it on the channel, and you also like my video. Thank you. Good day, viewer. We would be now continuing with similar triangles. This time also in our videos we have added a watermark which is from YouTube, and that also gives for subscription. So if you click on that watermark, and the watermark is like this, it's a red, and on which there is again a triangle, and the triangle is pointed towards your right. So if you click on this, it will immediately subscribe. So you don't have to go anywhere for this purpose. So I am grateful to all of you who have liked and also subscribed. I am looking for more subscription. Another thing I must tell you, that once you subscribe, you don't have to subscribe again. So you can keep on what are the subsequent videos are coming. So in this video we are going to discuss about similarity, continuing on similarity of triangles. So similarity of triangles. Now let us revise what we have done before. Number one, that we say two triangles, let us say triangle ABC is similar to triangle DEF. Okay, what does it mean? So let's draw those two triangles. So this is one triangle and this is the other triangle. Okay, so this I will mark as A, B, C, D, E, F. If I say these are, which means that there can be two things. One, these angles, the one word is very important, corresponding angle. What is the meaning of this corresponding items? That is what says, corresponding components or whatever you call it. That means angle A is congruent with angle D. So you can say angle A is congruent with angle F. No, this will be corresponding. So A is corresponding to D, and angle B corresponds to angle E, and angle C corresponds to angle F. So these are three angles, 1, 2, 3. The fallacy of the whole thing is this: you don't have to go for the third angle, because addition of A plus B, angle B, plus angle C will always remain 180 degree, no matter what kind of angle here, whether it's a scalene angle, whether it's an isosceles angle, or it is an equilateral triangle. This will remain the same. So if we take two, if we say that two are congruent, the third has to be congruent. So anyway, this is a system that is going on, that this is called A. But for our purpose, we can always take out double A, and say the third one definitely will be this. It will also be congruent. Another important thing that comes up is this, that again the corresponding sides or the corresponding angles. So if I take AB, I have to take DF is equal to, again go BC by EF, and that is equal to again CA or AC by FD or DF. Okay, these ratios should be same, and let us say this is equal to some constant K. Okay, this is in case of similarity. I will just transgress a little bit and say that in case of congruent triangle, this K becomes equal to 1. Again, this is a digression, this is different. I have diverged from my prepared this thing, so we will call this one is equal to K. So this is called, or conversely, if I can prove A is, so conversely, if I can prove, or one can prove that the two angles are congruent, and implied that the three angles are congruent, and this ratio is maintained, then I can say ABC is congruent to DEF. I hope this is in essence whatever we want to say about the similarity about triangles. So I will write it down that if we can prove, conversely, if we can prove that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. This is one. And also, if I again in another system I can prove AB, we don't have to do this one simultaneously. If we can prove AD equal to DE, this is DE, AD equal to DE, that is equal to BC equal to EF, that is equal to AC equal to DF, then I can say easily that triangle ABC is similar to triangle DEF. Is this clear? This is very, very simple. And this, with this system, with this knowledge or this information, you can do very, very interesting problems. So I'll pick up the first one, which I'll release this board, and we'll pick up the first one. See, it's better to draw on the board because you also know how to draw a triangle and what are the signs in this thing. There is no use of just sleight of a hand that you will end up getting the figures. Okay, so here I have a triangle. The problem is like that, this. I have a triangle and remember the nomenclature, how I am doing this. Okay, this is A, this is B, and this is C. Okay, now from here two things is given. It is given that this angle is 90 degree. Okay, okay, let me take a little bit of time to draw this one. Really, I was talking about sketches, then I will really do it. This triangle will come like this. Then it will show up properly that this angle is 90. So this angle, now you know, you can easily see this angle is 90. And then from here, so now this angle becomes 90. Okay. Now from here, a perpendicular is dropped on the opposite side. Opposite side means AC side. Okay. So this perpendicular, this will be D. So this is what?
So
So this is D. This point is D. And since this is a perpendicular, I can say these two angles are 90 degree. So this is 90 degree, this is 90 degree. So this is given, this is given, this is said, perpendicular is said, that means these two are also given, this is given, this is also given, and AD equal to 6, that is also given, okay. DC is equal to 2, that is also given. So these are given. And so what is being asked? It says find out BC. These type of questions you cannot solve without the help of similarity of the triangle. There is no other way. So what do? We'll take angle. We will take this triangle. This triangle means smaller triangle. And we will show that this is similar to the triangle ABC. How do we show? So we want to show triangle BDC is similar to triangle BAC. Triangle BAC. Okay, this is okay. Now, how do I show this? See, angle C is common. Angle C is equal to angle C in both the triangles. Okay, this is a common angle. Common angle, right? So I don't have to worry. Now, this angle BDC is equal to angle ABC. Both are 90 degree. So two angles I have shown. That means I can claim that so the third angle, let me put it the third angle even though it is not necessary. Then I can say angle BDC is equal to angle BAC. Okay, this is not required, but still, if anybody is this thing, we may use it later on. So this is proven that triangle BDC is similar to triangle BAC. Okay. Now what do I have to do? Now I have to find the ratio. I need to find out the ratio and relate to 6 and 2, which is only given to me. So I will erase this part of it and then show you. The best way is to take these triangles out. Okay? So let me take out triangle this triangle I will take out. This triangle is ABC with 90 degree here, and I will take out this angle, this triangle, not angle. So I will take out this angle. This angle will be BDC. And here triangle is here. Right? Okay. Now, and what is given? AC will be 6 plus 2. That is will be equal to 8. And DC will be 2. These are all given. This 6 plus 2 was given, and we have added up. Now we have to find out the corresponding sides so that I can take a corresponding CPTC, corresponding part of, I will change it, of similar triangles. I will call it CPST, corresponding parts. So which one are the corresponding parts will be? if you see, one is very easy to visualize, or I can flip this triangle over. If I can flip this triangle over, this will be again easy. How do I flip this triangle over? I will have B here as my 90 degree, and I will draw this one. So this is B. Okay. Now I have flipped it over. That means this has come here. So this will be A and this will be C. Okay. So here you can flip it over, or you can do it like this. See, this is 90 degree. So its opposite is AC. This is 90 degree. Its opposite is BC. So I can write AC by BC. So again we can see opposite to angle C here. Opposite to angle C is BD and opposite to angle C is AB. So AB by, I can see opposite to angle, this is BD. BD, right? Opposite to this thing. Again, you can see, I can again use the same thing, say opposite to angle A. So which one is opposite to angle A? What is remaining now? Remaining A, B, AC, I have said. I now have to take on this one is another BC. Okay, because BC is not there. Again another BC, and here, sorry, I am doing something wrong. I am doing something wrong. AC by BC, this is okay. AC by BC, then BBC. No, I am doing correct. Okay, and this will be equal to DC. Okay, because BC has been taken, BD has been taken, CD I have taken. Either you write DC or you write CD. Okay, this is perfectly okay. Now I will relate this ratio, okay, and this ratio. So I will relate 1 and 2. So relate 1 ratio and 2 ratio. Relate 1 and 2. So what do I do? I'll come on this side. AC by BC is equal to BC by DC. Or you can write down CD, whatever way you want to look at. That will be what? That will be BC square, this and this will be cross multiplied, BC square, that will be AC into DC. We continue so that we don't have to change. What is AC? AC is 2. AC is 8 and DC is 2. That makes it 16. Okay? Therefore, BC is equal to root of 16, that is equal to 4. So we got the BC. So what find out BC equal to 4? I thought it is a very interesting this thing. You can flip it over, you can do it, or you can do opposite angles and then find out the corresponding. This corresponding parts is very important. Please pay attention from now on, because this corresponding parts, this is on similar triangle. Similar triangles, then this should be congruent triangle when we go for congruency of triangles. Okay, I'll go through another very interesting problem, and that will also be, so what is the reach, how much is the reach of this similarity of the triangle. Unfortunately, in class 9, they jumped directly to congruency of triangle. Instead of spending time, or instead of putting in a chapter on similarity of triangles. I think that should be a similarity of the triangle should be taught before you go to congruency of triangles. I hope its a revision is required by NCRT for their book on this issue, on their mathematics book. What we are now going to do is, again we have to take triangles, we are again going to take two triangles here by side, so that I can save on the board space and I can write more. I don't have to go down. So this is A, B and C. This is D, E and F. Whatever it says, it's given that these two triangles are congruent. A, B, C, E, sorry, not congruent, similar to triangle D, E, F. What they want to us to find out what? Ratio of areas of both the above triangles. Both the above triangles. Okay? Both the above triangles we have to find out. So once it is given us this is, what does it give? It says angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. This is given. Further, what is given? Further it is given AB by corresponding parts BE, that is equal to BC by EF, that is equal to AC by DF. This is given. All this is given once you say that they are similar. So all this is given. So I have to find out the ratio of the areas. Now you know, other than Heron's theorem, the only other way of finding out the area of a triangle would be to find out through drawing altitude. So altitude is you draw perpendicular from vertex to the opposite side. So let us call this one as T and let us call this one as S. So what would be the area? First let us find out the area. So area would be of triangle ABC would be half base into altitude. What is that? What is its base? ABC. Base is BC and is half. So the half should be continued. The BC is there and what would be there? And AT. Agreed? Has to be. There is no other alternative. Okay. Similarly, triangle DEF area. Okay. Same. Do. Okay. Half base into altitude. It will be half. This time EF and DS. Okay. Now you have to find out the ratio. So if I take out the ratio, would be half BC into AT divided by half EF into DS. Okay, half cancels. So I will have BC into EF and here I will have AT by ds. Okay. Now let us see these two triangles. This triangle, half of this triangle, this side, left hand side, okay, and this triangle. Okay, this is given. B is E. So here I can write B is equal to E. Right? Given B is equal to E. This is given. Okay, what else is given? This is perpendicular. So this angle ATB is equal to DSE. That is both of them are 90 degrees. Okay, by all this thing. So I can easily say that triangle, okay, ABT is similar to triangle DES. This is agreed? And here this thing is this one. So what I can say, these ratios, corresponding parts, okay, use corresponding parts. So corresponding parts of similar triangle. So if I do that, then in that case I can write AB by DE. AB, so corresponding part is this. So this would be DE. So I have started with, so AT by DS. AT by DS. Okay, fine. Now I can write down also that AB by DE would be what? Would be AB by, no, here is something here. AB by BE, no, it will not be BE, it will be DE. B कहाँ से आएगा? दोनों ट्राइंगल में AD by, this should be DE. So AB by DE, AB by DE was given is equal to BC by EF. So I can write also is equal to BC by EF. Okay, mark this one. This was in, I am taking this triangle. In this triangle, the previously A was written, was not appropriate. It should be AB by DE. So if you take this one, now this AT by DS, I can substitute BC by EF here. Okay, so I will do it then. It will be equal to BC by EF, okay, BC by EF into BC by EF, BC by EF. That is equal to BC by EF square. So any of this ratio now, anyone now, BC by EF. So that means it should be also, it will be AB by DE square. This will be also equal to AC by DF square. AC by DF square. So the ratio of area of two similar triangles is the square of the ratio of their corresponding parts. Okay? Stop. Okay. Now this is another very good exercise. What it says, it has a angle. It has a triangle. Now doing angle and sum, it's always angle comes in the mouth. So this is a triangle. Let's call it ABC. And this angle, this A angle is bisected. Okay, and this, let us call it B. What we have to prove, this is called Bisector Theorem. Bisector Theorem. We have to prove AB by BD. AB by BD would be equal to AC by CD. Okay? So that means if these two are there, this is called bisector theorem. So in order to do so, what I have? I have only 1 and 1. This is bisected. I don't have anything else. So in order to generate those, what I will do, I will draw a line which is parallel to AB or BA. So draw a line. Okay? And extend this and let it cut to BD. Let us call it E. Okay? Let's call it E. So what I have done, constructed EC parallel to AB, okay, joining AD to E, joining extended AD to E. So two things, even though it doesn't look that way in the sketch, it should be. I think I should, in order for us to visualize, I will do it in such a way, so that it becomes really parallel. So I'll take it down a little bit. Okay. Now this sketch looks much better. So if you have this parallel and this one parallel, and this would be then a transversal. If that is true, then I can say this angle 1 is equal to this angle 1. If that is true, then, okay, E I have again missed. So then AC equal to EC. So this is now comes out to be an isosceles triangle. Let us see what else I can get out of it. Okay? Now, okay. In these two triangles, what are the two triangles? Always be careful, this and that. So be careful about this, what is being said. So I am talking about angle ABD, and angle and triangle, sorry, not angle, again that same problem. Triangle EDC. Okay, why I have done it? Because I am now trying to correspond. I am trying to correspond this thing. So in these two triangles, I can show angle BAD, which I have done it before. Angle BAD is equal to angle DEC. DEC. Why? They are alternate angles, right? Because EC is parallel to AB. There is another alternate angle coming up, that is this angle and this angle. So let me call this one angle 2 and this one angle 2. Why? This is parallel, this is parallel, this is transversal. So I can say that angle 2 is equal to angle 2, right? So angle 1 is already I have proven. This one I will mark it also, angle 1 is equal to angle 1. So out of these two triangles, I have already proven two angles which are equal, or you can say they are congruent. Okay, they are equal and congruent because they will sit on top of it. So that means these two triangles, triangle ABD is similar to triangle EDC. This is okay? Okay. Then I can start taking ratios. How do I take ratios? What kind of it? So you see, this is angle 1, okay? And first of all, these two triangles are also equal. Why? Because they are vertically opposite angles. So we can say, so let us take AB by AB किसका है ऑपोजिट? इसका ऑपोजिट. इसका ऑपोजिट क्या है? EC. ठीक है, अभी देखते हैं. अभी 1 का ऑपोजिट क्या है? 1 का ऑपोजिट, अच्छा इससे शुरू किया तो पहले इसके 1 का ऑपोजिट है BD और इसका ऑपोजिट है BD का ऑपोजिट कौन सा होगा? इसका ऑपोजिट कौन सा है? इसका ऑपोजिट है CD. ओके, अगेन another one that we can say is, इसका तो हो गया, अभी इसका भी ऑपोजिट ले लिया. 2 का ऑपोजिट क्या है? DE. So let us take, इससे शुरू करें, इस ट्रायंगल से शुरू करें, ये गलतियां ना करें. AD. So AD is इसका ऑपोजिट, 2 का ऑपोजिट क्या है? ED. So ये सब रेशियो हमको आ गया. अभी हमको प्रूफ क्या करना है? Is AB by BD is equal to AC. अच्छा, और एक चीज आप देखो यहाँ पे EC, I can say EC is equal to, ये मैंने कहीं नहीं लिखा था पहले, EC would be equal to AC. क्यों? Because this is an isosceles triangle. Why? Because angle opposite, sides opposite to equal angle. Why? Sides opposite to equal angles are equal. Right? So sides opposite to equal angles are equal. Sides, इसमें ऐसा आएगा. Sides opposite to equal angles are equal. So that's why I can write EC equal to AC. तो अभी हम क्या करें? इस जगह में जो EC लिखा हुआ है, इसमें हम AC सब्स्टिट्यूट करें. So AB by AC would be equal to BD by CD, right? BD by CD. So you can change it, you can do it this way, or you can write this one, also write AB by AC is equal to AB by AC, so BD by CD. Okay, I can change here also. AB by BD is equal to this thing. So this is proved. Okay, AB by AC, BD by this thing. So look at this and also look at that. Fine. I think we have done very two interesting problems. There are many more interesting problems. I think this video is going too much. I mean, the length is increasing. So we will stop it here, and thank you for your patient hearing. Thank you very much. Bye.